Imagine South America millions of years back. Big predators roaming around, totally unlike anything today.
Yeah, it's a wild thought.
And that's where we're going today, diving into Abelisaurus. It's a really fascinating dinosaur from the late Cretaceous.
Mm,
You sent over some fantastic source material on this one, and our mission basically is to pull out the key stuff about it.
right. Get to the heart of Abelisaurus.
Exactly, like its discovery, how scientists, classified it, and what it tells us about that whole period.
And it's important to remember right off the bat that a lot of what we think we know,
Mhm.
it comes down to just one partial skull.
A single skull.
Yeah. So there's this built-in mystery,
Yeah.
It really shows how paleontology is always this ongoing search. So where does the story of the skull even kick off?
Good question. It's like having just one piece of this massive puzzle. So where did this crucial skull first surface?
Okay, so we need to go out to 1983. A guy named Roberto Abel, and his name is going to be important, obviously, in
Uh-huh.
Abel. Abelisaurus, I'm guessing? Yeah. Exactly. He found the holotype specimen that's like the main example for the species at a site they called Cantera de la Palamecánica.
The mechanical shovel quarry. Sounds industrial.
Kind of, yeah. It was near Lago Pellegrini in Argentina. And what's interesting is Abel had apparently been working that area since like 1975.
Wow, so he'd been digging around there for years.
Right, so it wasn't just a lucky break, it was, persistent work.
Makes you wonder what else might be hiding in those quarries. Okay, so he finds it, then comes the naming, right? How did Amblsaurus get that name?
That happened officially in 1985. Two big names in Argentine paleontology, Jose Bonaparte and Fernando Emilio Novas, they stepped in.
Okay.
They set up the genus Abelisaurus. It was a direct nod to Roberto Abel for finding it, and also because he used to direct the museum where the fossil ended up.
Makes sense. A fitting tribute.
Definitely. And then they stuck Soros on the end, which is just Greek for lizard. Standard practice, really. So Abel's lizard.
Simple enough. And the species name, Comahuensis. Where does that come from?
That points to the place. It's named after the Comahu region of Argentina, where they found it.
Right, so it pins it geographically.
Exactly. Abelisaurus comahuensis tells you where and kind of who brought it to light. So this main fossil, the holotype, what exactly did they find? What condition was it in?
Yeah, what did the skull actually look like? Was it complete?
Well, no, not really. It's cataloged as MC1Fen98, and it was definitely partial. The lower jaws, totally missing.
Oh, wow.
And the right side was apparently more busted up than the left. Lots of the connections between like the snout and the back of the skull were gone.
Yeah.
And most of the roof of the mouth wasn't there either.
So quite fragmented then.
Very. But even with all that missing, by comparing it and doing some reconstruction, they figured the original skull was probably over 85 centimeters long.
85 centimeters, so like 33 inches.
About that, yeah. Even incomplete, it was clearly a big chunk of bone, hinted at a pretty serious animal.
Definitely. 33 inches for just the skull gives you an idea. Now, location, you mentioned Argentina, late Cretaceous, but I remember seeing something about the exact rock layer being a bit debated.
Ah, yeah, that's a good point. It gets a bit complicated there. See, initially, they thought it came from the Allen Formation.
Oh, okay.
But then later studies suggested it was actually from an older layer, the Anacleto Formation. That's part of the Nuquin Group, also in Rio Negro Province.
And when was that, roughly?
The Anacleto Formation puts it in the early Campanian stage of the late Cretaceous. So we're talking maybe 83 to 80 million years ago.
Got it. But there was some uncertainty.
Well, yeah. There's also this, local knowledge that connects the find to a specific spot, the Cien Fernandez Field, which is thought to be in the Allen Formation, which is also Campanian but maybe slightly younger.
Huh. So it's not totally crystal clear.
Exactly. It shows you the real-world messiness of figuring out exact dates and locations. It's not always neat like in a textbook.
Fascinating. So pinning down its precise address and time is tricky, but generally early late Cretaceous. Okay, let's shift from the where and when to the what. What did the skull actually tell us about what Abelisaurus looked like, physically?
Okay, well, even just from the skull, you can make some basic deductions. Based on its shape and comparing it to other related dinosaurs, theropods, it was definitely bipedal, walked on two legs.
Right. Carnivore?
Oh, absolutely. A meat eater.
Right.
But the big question, because we only have the skull, is how big was the whole animal?
Yeah, that's the million-dollar question, isn't it? Like trying to guess how tall someone is just by seeing their hat.
Pretty much. A very large bony hat in this case.
So what are the guesses? What sizes have scientists thrown out there?
Well, it's varied quite a bit over the years. Gregory S. Paul, back in 2010, he estimated maybe 10 meters long, that's nearly 33 feet and weighing around 3 tons.
Okay, that's substantial.
Then Thomas Holtz, a couple of years later, suggested it could have been even bigger, maybe up to 11 meters, over 36 feet.
Whoa, even bigger.
But then a more detailed study in 2016 kind of scaled it back a bit. They came up with about 7.4 meters, so around 24 feet.
That's quite a difference from 11 meters.
It is. And around the same time, some other researchers suggested maybe 7.2 meters, about 23.5 feet, and lighter too, like 1.65 tons.
So the estimates are really all over the place.
They are. It just highlights how difficult it is when you're working from incomplete material.
Yeah.
You know, a few meters difference in length changes everything about how you picture the animal, how it hunted.
Totally. An 11-meter versus a 7-meter predator is a different beast entirely. Shows how much is still up in the air. What about the skull itself? Any, standout features?
Yeah, definitely. It was noted pretty early on for being quite deep, top to bottom, and looking pretty sturdy.
Robust.
Right. And interestingly, you know how some other abelisaurs, like Carnotaurus, have those crazy horns?
Oh, yeah, the really distinctive ones.
Well, Abelisaurus didn't have big bony horns like that. But it did have these rough, bumpy ridges on the snout and over the eyes.
Okay, so what were those for?
The idea is that maybe those ridges supported structures made of keratin, like, fingernails or rhino horns.
Ah, so maybe softer crusts that wouldn't fossilize.
Exactly. So it might have had some kind of display feature, maybe colorful, maybe just textured, that we can only guess at from the underlying bone.
A sort of ghost decoration.
Yeah.
Cool. What else about the skull structure?
Well, the skull roof, the top part, seems quite thick, maybe for protection.
Makes sense for a predator.
And it had these big openings, fenestrae, which are common in dinosaur skulls. They help make the skull lighter without losing too much strength.
Like natural weight reduction?
Kind of, yeah.
Yeah.
There's a big triangular one on the side of the snout, the interorbital fenestra. And the eye socket itself was tall, but it was sort of pinched in the middle by bones in front and behind it.
Pinched? So where was the actual eye?
The thinking is the eye sat above that pinched part. Might have given it a decent view. And behind the eye socket, there's another big triangular opening, the infratemporal fenestra. The way it's angled suggests the whole back of the skull sloped forward quite sharply.
Lightweight, but strong. Nature's engineering, right?
Very much. A common design for active hunters.
And the teeth. Got to talk about the teeth.
Right. So at the very front, in the premaxilla bone, it had 4 teeth that were relatively small.
Okay.
But then further back, in the main upper jaw bone, the maxilla, there were at least 7, maybe up to 13 larger teeth.
Ah, a mix of sizes. What does that suggest?
Well, it fits the pattern for a carnivore, probably good for grabbing and tearing prey. That difference between front and back teeth is pretty typical for theropods.
Okay, so we're getting a clearer picture. Big, two-legged predator, deep skull, maybe some keratin crests, different sized teeth for munching. Now, where does it fit in the bigger dinosaur family tree? How is Abelisaurus classified?
So when Bonaparte and Novus first described it in '85, they didn't just name the dinosaur. They actually created a whole new family for it, the Abelisauridae.
Ah, so it's the namesake for the whole family.
Exactly. It was the very first abelisaurid to get a name. At the time, they put this new family inside a bigger group called Carnosauria.
The original Abelisaurid, that's pretty significant. But I know our understanding of these groups has changed a lot since the 80s, right?
Oh, massively. Since Abelisaurus was found, paleontologists have uncovered loads more abelisaurids, and many of them are much more complete. Famous ones like Archosaurus, Carnotaurus, Majungasaurus.
Right, the ones with horns and weird skulls.
Yeah. And studying those more complete fossils made scientists realize that abelisaurids, while definitely meat-eating theropods, weren't actually carnosaurs in the modern sense of that group.
So where do they belong?
They belong to a different branch, an older lineage called Neoceratosauria. So it was a pretty major reshuffle based on that new evidence. Really shows how science evolves.
Okay, so they move the whole family. What about Abelisaurus' spot within the Abelisauridae family? Is it an early offshoot or closer to things like Carnotaurus?
That's still a bit fuzzy, actually. There's some debate. Some researchers think Abelisaurus is quite basal, meaning it branched off early in the family's history, before the subfamily Carnotaurinae, which includes Carnotaurus and its closer relatives.
But it's not settled.
Not entirely. Others aren't so sure. Because we only have that one partial skull, it's missing some of the key features you'd find elsewhere in the skeleton that really help nail down those relationships. So its exact position is still kind of an active research question.
Sounds like we desperately need more Abelisaurus bones. Now, I also saw something comparing it, maybe just superficially, to the Carcharodontosaurids. Like Giganotosaurus. That seems like a different kettle of fish.
It is a different kettle of fish, you're right.
Yeah.
But it's a good point about similarities. Abelisaurus does share some general skull proportions, like being relatively long, with Carcharodontosaurids, who are also giant predators around the Cretaceous.
So just looking similar because they did similar jobs, convergent evolution.
That's the most likely explanation, yeah. Because Abelisaurus is just known from the skull. Someone somewhere speculated early on that maybe, just maybe, future finds could even prove it was a Carcharodontosaurid.
But that's not likely now.
Extremely unlikely, based on the skull details we do have and what we now know about both groups. Most paleontologists think the resemblance is superficial, driven by filling similar ecological roles as big predators.
Nature finding similar tools for similar tasks.
Gotcha.
And there was one other classification note, something about potentially lumping it with Aucasaurus.
Ah, yes. So Fernando Noves, remember one of the original describers, in 2009, he suggested that maybe Aucasaurus gyrodoi, another abelisaurid from South America known from better fossils, was actually the same thing as Abelisaurus comoensis.
Oh, so Aucasaurus would just be a synonym.
If that were true, yes. Abelisaurus was named first, so its name would stick. And Gregory Paul even went ahead and called it Abelisaurus gyrodoi in 2010 based on Novus's suggestion.
But did that idea catch on?
Not really, no. It hasn't been widely accepted. Most researchers still think Aucasaurus has enough unique features to be considered its own separate genus.
Okay, so Abelisaurus remains Abelisaurus. Good. Let's shift gears slightly. What about its life, its paleobiology? What can we guess about how it lived?
Well, going back to Bonaparte and Novus, they looked at the skull, especially how broad it was at the back, and saw similarities to tyrannosaurids, like T-Rex.
Ah, the wide skull base.
Right. And based on that, they proposed that Abelisaurus might have played a similar role in its ecosystem. The apex predator, top of the food chain in late Cretaceous South America.
The local T-Rex equivalent, maybe? And what would it have been hunting?
Gregory Paul, again in 2010, speculated that it probably went after the Titanosaurs.
The huge, long-necked sauropods?
Exactly. South America was lousy with them back then. Things like Anarctosaurus, Pellegrinosaurus, Barosaurus, Nuconsaurus. Those were potentially on the menu.
Wow. Imagining a fight between an Abelisaurus and one of those giants. That's epic.
It really puts the scale of that ecosystem into perspective, doesn't it? Just mind-blowing power dynamics.
Definitely. And just to recap the setting, this was all happening during the Companion stage, late Cretaceous, modern-day Argentina. And the fossils specifically came from the Anahuato Formation, even with that little bit of location fuzziness we talked about.
That's the picture. A truly different world, filled with these incredible giants.
Incredible. Okay, as we start to wrap up this deep dive on Abelisaurus, what are the main things you think people should take away?
Well, I think the key points are, Abelisaurus was a major predatory dinosaur in late Cretaceous South America. Almost everything we know, though, comes from that single partial skull found in Argentina.
Right, the incomplete puzzle piece.
Exactly. Its size is still debated, with estimates varying quite a bit, but it was definitely large. It defines the Abelisauridae family, even if its exact spot within that family isn't totally clear yet.
Okay.
And given its likely size and the other dinosaurs around, it's probably a top predator, maybe tackling those enormous titanosaurs.
But always with that caveat, we're basing so much on just that one skull.
Always. It's the classic paleontological challenge, isn't it? It shows how much you can learn from fragments, but also how much is still waiting to be discovered.
It really highlights how paleontology is this constantly evolving story.
Absolutely. Every new find, even a single bone, could potentially shift our understanding of these amazing animals and the worlds they lived in.
Which brings us to a final thought for you listening in. Since our whole image of Abelisaurus hinges so much on just that one partial skull, imagine what finding other parts might do. What if someone found a complete leg, or a tail, or dream scenario, a whole skeleton? How might that completely change our ideas about its true size, how it moved, how it hunted?
Yeah, it could rewrite the book.
And what does relying on such patchy evidence tell us about, well, the challenges, but also the sheer excitement of trying to piece together life from millions of years ago? It's a deep dive that's definitely far from over.